All right, hello. Today we're going to be talking about torque converters, what they do for us, why we need them, and how they operate, and the parts that make one up. So I'll try and make this quick, but all right, let's get to it. So in a manual transmission, when you come to a stop, a car with a manual transmission, you come to a stop, if you don't push in that clutch, or if you're not in neutral, the engine will stall, right? That clutch gives us that ability to connect and disconnect the engine from the rest of the driveline, allowing us to come to a stop or disrupt power flow to change gears. But in an automatic transmission, we don't have a clutch. You don't have that clutch pedal to manually disconnect the engine and the transmission to allow the car to come to a complete stop. So the part that takes the place of that clutch in an automatic transmission is the torque converter. So a torque converter is what gives us that disconnect from the driveline and the wheels and the engine. So how do we do that? Well, inside torque converters, there are parts that aren't physically connected. So the input shaft of the transmission is connected to one set of parts inside the torque converter, and the crankshaft of the engine is connected to another set of parts, and those parts are not physically connected in any way. Most of the time. Under some situations they may be, but we'll get there. So the earliest torque converters weren't actually called torque converters, they were fluid couplers. And luckily what we have here is the fluid coupler right out of Sal's Oldsmobile. So what we have here is the inside, and this part is the housing, and this part is what bolted to the engine itself, right? You see this outer housing and all these bolt holes here around the outside, that this was bolted to the flywheel of the engine. So all right, what's inside here is the actual fluid coupler itself. So think about it. The housing is connected to the engine, and it turns at engine speed. And then we have one half of this connects to this housing. And this would be our pump or our impeller. And so this piece is going to spin at the speed of the engine. And if you see inside here, there's a bunch of fins here. And these fins are all mounted to this housing. And so when the engine turns and this outer piece is turning, this will be turning. And this is going to be filled with transmission fluid. And the act of this spinning causes that fluid to be pumped inside here. Just like a water pump or something like that. It's going to be pumping this fluid and moving it through these veins here. And the fluid is going to move from these veins into these. And this is the other half of the torque converter. This piece is called the turbine. And the turbine is going to be connected to the transmission input shaft. So as the engine is spinning and that fluid is being pumped around by the impeller or the pump of the torque converter, that fluid is going to act upon the turbine portion of the fluid coupler and start it turning. And the faster the impeller spins, the more the fluid is flung out, and the more the turbine is going to spin, and it's going to put the power to the input shaft of the transmission. Now, this process is very energy inefficient. A lot of torque and everything is lost in that transfer of the energy through fluid. So these early automatic transmissions with these fluid couplers, they didn't have very good power delivery, and they kind of gave automatics a bad rap because of that. But here, what we have here, this big box, this big blue piece here, is an actual modern day torque converter. So fluid coupler and torque converter. So if you see here, we have 3 bolt hole areas here, and this would bolt to the flywheel of the engine. So this housing is bolted to the engine. So this entire assembly is going to spin at engine speed. But then you notice inside here, we have kind of a hollowed out little input in there. And inside here, let's take this apart. We have something similar, but also different, right? What we have here is our turbine, just like we had in the fluid coupler here. But you notice it's got a little bit different design, right? These fins are angled inside here. It's a little more elaborate of a design. And then we have our housing, again, remember, so our this portion of the housing bolted to the engine, the flywheel, with these bolt holes. This part of the housing, which is usually welded together, is connected there. And this is our turbine, which is housed inside there. The turbine is splined to the input shaft of the transmission. And you notice our impeller is part of the housing. So remember, our housing is bolted to the flywheel, so our impeller is turning at flywheel speed. It is, you can't separate these two pieces, that's all welded together. And our turbine sits in there and is connected to the input shaft of the transmission with these splines here in the middle. So now we have the engine turning this portion, the impeller, and this fluid is being slung out and pumped around kind of in a circular pattern, right? It's drawing the fluid in the middle and forcing it out the outside at speed back around to the vanes here on our turbine, which, just like with the fluid coupler, starts to transmit that energy and that power, starts to spin our turbine, and the fluid exits through these fins and back into our impeller, where it starts to cycle again. This is still a fluid coupler at this point. But what we have here is a stator. And this sits in between here, in between the impeller and the housing and the turbine. So as this component is being turned by the engine and the fluid is being pumped out, the fluid then enters the turbine here, starts it moving, and then exits through these fins. Well, what our stator does is it gives that fluid a little bit of an angle change, right? If you can see down in there, these fins here direct the fluid. The fluid will go in, hit these fins, and it gets directed at this, at the impeller at a harder angle, and it actually starts to help spin the impeller. So it starts to assist the engine. It starts to give it a little extra boost because of the angle of the fluid hitting these fins. And so that in turn increases the speed of the fluid hitting the turbine. So it's multiplying the torque. That's where we get the term torque converter. So this stator assembly, and the way it is changing the direction of the fluid flow, is actually increasing the torque of the torque converter, is increasing the output of the torque converter. Now, that all is active when we're first taking off, and the RPM of the impeller is at engine speed, and the RPM of the turbine is at the wheel speed, or transmission input speed. So there's a huge difference in speed in between the impeller and the turbine. So the stator is going to be most effective at that large speed differential. The stator has a one-way clutch in it that allows it to only turn in one direction. So when the fluid is hitting the vanes on the stator, it's directing the fluid at the impeller vanes to increase that torque. But when I hold this centerpiece here, you notice it doesn't move. Well, this is during that large difference in speed of the impeller and the turbine. As that speed starts to match and it gets closer, the car's speeded up and it's getting up to speed, the fluid is hitting this at much less of a sharp of an angle. And it'll eventually end up hitting the fin almost straight on, which then you notice there's a one-way clutch in here that it's going to allow this to start to turn. And so as this starts to turn, that torque multiplication that happens starts to taper off and eventually will go away completely. So because we don't need that much torque once the car is up and running, right? So this is kind of a self-regulating device. A torque converter, it's not adding huge amounts of torque to the driveline, but it can add up to 2 times the torque at low RPMs. So now we have our torque converter now, which this part is the stator, and that torque multiplication is what's going to separate it from a fluid coupler that we saw in the older cars. So there's one other component here that we need to talk about, and that is our torque converter lockup. So once the torque converter is doing its job and we've gotten up to speed and the car's driving down the road, we no longer need this fluid coupling, right? We don't need this disconnect from the wheels and the engine. So let's back up. This process, this fluid coupling and this fluid transfer and this torque converter, it generates a lot of heat also. So a torque converter, we don't want it working all the time because it'll overheat the transmission fluid too quickly. So to avoid that, what we use is a torque converter lockup clutch. And that's what this part here does. You notice it splines to the turbine. So we have our turbine splined to our torque converter clutch here. And you notice it looks very similar to a clutch in a manual transmission in the fact that it has these radial springs here that help absorb the jarring application of this clutch. So this helps smooth out that application when you apply the torque converter clutch. So the torque converter clutch is splined to our turbine, and that sits in here next to our impeller. So as our car starts off, the impeller is turning with the housing. The fluid starts to turn our turbine, which is connected to the transmission input shaft. Well, once we get up to speed, we no longer want these to spin at different speeds and generate all that heat and lose that energy. So the torque converter clutch, you see, has friction material here on the outside. And then we have a smooth area inside here in our torque converter housing. Well, this housing sits here. So when the torque converter solenoid applies fluid in here, it applies that clutch it's going to press on the back of this surface area here, and it's going to press this clutch against the housing, which is going to lock the entire torque converter as one unit. So we no longer have that fluid coupling, we have an actual mechanical connection. And that's why we need these springs to help smooth out the vibrations of the engine and the application of the clutch and make sure everything's as smooth as possible. So that's the components in a torque converter. One of the things I want to point out also about the torque converter is you'll notice here on the housing we have our mounting bolt holes, but also you see this round portion in the center. Well, that portion in the center rides in the center of the crankshaft. So this helps center the torque converter in the crankshaft and keep it from being off balance and off centered. Also, one other thing about the housing is if you look at this side and you look at the snout here, this part would go into the automatic transmission. The input shaft of the automatic transmission would go in the middle here, through the middle, and spline into the turbine. But also you'll notice we have these two little tangs here, these little cutouts. Well, what this does, these cutouts, is transfers the engine movement to the pump. So an automatic transmission has a pump that generates the hydraulic pressure that we need to apply clutches and do other things inside the automatic transmission. Well, the drive for that pump is the snout of this torque converter. And these two little indentations here will engage with the drive ears of the pump so that when we start up the engine, that transmission pump is always going to be pumping and generating hydraulic pressure. So our torque converter is also our transmission pump drive. So, all right, so that's the components and how they work together pretty much. I'm going to go out in the shop and set up a demonstration. I'm going to start the camera up out there and we'll go through a demonstration to kind of help illustrate what's going on in here a little bit better and maybe make a little more sense. But so see you in the shop. Hello, welcome to the shop. So I've got the display set up here that I talked about inside. So let's start it up. So we got two fans here facing each other. This fan here is plugged in to electricity, so it can turn on. This fan is not hooked up to any power, so this one is not going to turn on its own power. So this fan is going to represent the impeller inside that torque converter, and the electric motor of this fan is going to represent the engine, the car's engine. So as soon as the engine starts turning, the impeller is going to start turning and it's going to start pushing air. Here it's pushing air, but in the torque converter the air would be replaced with transmission fluid. So as soon as this impeller starts to spin and it starts to push the transmission fluid towards the turbine, you're going to see the turbine is going to slowly start to pick up speed. It'll start to pick up and start spinning. Remember, this is the input to the transmission. So engine power is being transferred to the transmission through this transmission fluid here. So these fan blades are going to act like the veins inside the impeller and the turbine. So as soon as I turn on this impeller, you're going to see this is going to come up to speed really fast, just like an engine. The turbine, you're going to notice, is going to take a little bit. It's going to start taking its sweet time to kind of build up to speed, but eventually it'll match this, not quite match, but almost match the speed of the impeller. This here would be the fluid coupler, like we saw in the old Oldsmobile transmission. We don't have a stator here to help magnify the torque or help multiply the effect of the air hitting these fan blades. But if this was a true torque converter, we would have a stator in here that would kind of redirect the air to hit these fan blades a little more direct and straight on to help get them moving a little bit faster. And as the fans started to match speed, that effect would be lessened and lessened until they were almost at matching speeds. So I'm going to turn on this fan again, just like I was starting the engine, and it's going to start transferring the power from this engine to the turbine, which would transfer it into the input of the transmission. So here we go. Notice it starts off really slow. Large differential of speed. The stator is doing the maximum amount of torque multiplication. Quickly, the turbine is coming up to speed and matching the impeller. That stator would become less and less effective until the maximum turbine speed was almost but not quite matching the speed of the impeller. So again, nothing hooked up to this fan. It's purely being pushed by the air from this fan. So this is what we have going on inside a torque converter. There is no mechanical connection between the two pieces, which gives us that ability to bring the car to the stop, to have the wheels stop and the driveline can quit moving, and quit rotating, but the engine continue to rotate. I could, if I wanted to, stick my finger in here and bring this fan to a stop, even though this fan is still running. And that's exactly what goes on inside of a torque converter. The wheels and the transmission and all that comes to a stop from the brakes, which is what's holding the turbine from moving. So, there you go, our turbine is still spinning, our impeller is turned off. So hopefully that helps clarify a little bit of what's going on inside the torque converter in an automatic transmission. So thank you very much, and see you in the next video.